In this video, we're going to talk about function notation and how we can represent things that are functions using equations. To start, we'll remember that a function is basically like an input-output machine. So we put an x value into a function and it outputs a y value. That's the result of some operations being applied to x. So x we will always label as our input and y will always be labeled as our output. Now the function in between could be made of any sorts of operations, multiplication, division, addition, subtraction, and so on. And so that will always differ, but the notation we can use to now represent anything that is a function is this notation I've written in the box. Now when we read that out loud, we'll say it is f at x. So that's the function f at a value x. So we're basically assigning a unique identifier of what the function is by using the letter f, and we're saying the value of that function at this input of an x value is going to give me my y value. Functions, you can use any sort of letters for the naming of them. F is the default because of the word function, but you can use any letter of the alphabet. It could be capitalized, it could be lowercase, and it still represents a function. So for example, I could write out a function that I call g of x, and that function might have the equation 2x minus 3. And so what function notation allows me to do is distinguish between functions. So if I'm working with a bunch of functions at once, I don't have to refer to them all as y equals. I can actually say this one is f at x, this one is g at x, this one's h at x, and be able to tell the difference very easily. It's also really useful then when I want to substitute a value into the function. So if I decided to evaluate this at x equals 3, no longer do I have to write a sentence that says at x equals 3, this function is equal to something else. What I can actually do is substitute that x value directly into the function. So I can say g at 3 is equal to, and then in the actual equation, I will replace the x values that appear with that number I'm substituting in. So I'll do 2 times 3 minus 3 here, and then I can evaluate that. So that's 6 minus 3, so it's equal to 3. So that's the way function notation allows us to more clearly communicate what values we're substituting into a function and what values or what equations we're using and what values we're getting out of a function. In fact, this lets me very clearly represent that ordered pair now because I can write that g at 3 is equal to 3. So now not only do I know that the point 3, 3 exists on a function, I know exactly which function it's on. It's not on f at x, it's not on h at x, it's on g at x in this instance. So we'll do a quick example just to look at how the notation works, because I really want to cement the idea that this is a function with an input and an output. So whatever goes in those brackets after the name of the function represents the input. So for this first one, I'm saying I'm inputting 2 into the function above. So if I actually just look at that equation then, and I replace all my x's with the number 2, I've successfully substituted in the correct x value. So f at 2 is equal to 2 cubed minus 4, and I can evaluate that, and the result would just be 4. If I move on to part B, this one's a little bit more abstract. I'm no longer substituting in a number for x. I'm actually saying I'm going to substitute in a new variable a in the place of x. So if I want to know the value of the function at a, I'm just going to take the function, replace every spot I see in x with an a instead. So instead of it being f at x is equal to x cubed minus 4, it will now become f at a is equal to a cubed minus 4. And there's no further I can simplify that. There is still a variable in the mix, so that would be the end of that particular question. For part C, I've made it even more abstract by not just putting a variable or a number into the function. Here I'm inputting a full expression into this function, but the mechanics work the same way. If I recognize that b minus 2 is the input into my function, that means that every spot I see in x within my function, I will replace with b minus 2. So this becomes b minus 2 cubed minus 4. So this is just a quick example of how function notation works. It's meant to clearly communicate which equation I'm looking at. So if it's f at x, g at x, h at x, it's meant to clearly communicate what's being substituted into the function and what I'm getting out of it. And it also more clearly establishes a connection between my x and y values. And so no longer do I have to write them separately or just write them in a point that's not connected to any function. It's actually made very clear from this notation where the point lies, which function it's on, what its coordinates are. All that information is very nicely connected. So there will be a lot of other algebraic developments you can do with this notation, but I hope from this very simple tutorial on how it works, you'll be able to kind of tackle some of those more challenging algebra problems as they come, just with this fundamental understanding.